I am Dr. Adrian Tai. I'm a materials engineer.
I am Bruno Braz. I'm a materials engineer here at the European Space Agency.
The air that we breathe on Earth contains molecular oxygen. This is two oxygen atoms bonded together. Now, the region of space near to the Earth, called low Earth orbit, still contains some of this residual atmosphere. However, the high-energy UV radiation from the Sun breaks down the oxygen molecules into oxygen atoms. This is called atomic oxygen. Spacecraft in low Earth orbit can encounter atomic oxygen. Certain materials are more susceptible to atomic oxygen erosion than others, such as carbon and silver. Aeolus is one of ESA's Earth observation satellites. It will operate in low Earth orbit and it will measure the profiles of the wind on a global scale. In an early design phase of the mission, the project approached the Atomic Oxygen Test Laboratory in order to measure the atomic oxygen resistance of one of the thermal control materials on the outside of the spacecraft. This material is called beta cloth. Beta cloth consists of very thin glass fibres woven into a cloth and then impregnated with a material commonly called Teflon.
The beta cloth material we were provided with contained graphite yarns. These yarns are made of individual carbon fibers. The presence of these fibers increases the electrical conductivity of the beta cloth material. However, it also makes it extremely susceptible to atomic oxygen attack. There is then the risk of fallen and dislodged particles to fall onto sensitive and critical surfaces of the spacecraft. And in space, there will be no way to wipe these surfaces clean.
Atomic oxygen isn't easy to produce on Earth. To generate the atomic oxygen, we use a high-energy carbon dioxide laser, and we focus this laser beam into molecular oxygen, and this produces an oxygen plasma. The oxygen plasma then expands into a vacuum chamber and accelerates the atoms onto the materials which we want to test.
We were provided with 3 large samples of beta cloth material. We had to cut them into the appropriate dimensions. After preconditioning the samples, we measured the initial mass, and then we loaded them into the atomic oxygen facility. In total, we performed 2 exposures with an additional intermediate inspection point where we visually looked at the samples. After weighing the samples, we noticed that there was a substantial mass loss when compared to the initial conditions. These lodged particles were collected on a collector plate that was positioned under the beta cloth samples during the exposure. They could be seen with the UV light.
Further analysis of the beta cloth was performed using the scanning electron microscope. In order to look at the surface of the cloth under extremely high magnification, we found that there are areas of the cloth where the Teflon coating was non-uniform and the underlying carbon fibres had been eroded by the atomic oxygen. This demonstrated that there was a real risk in orbit that these carbon fibres could be released from the cloth and damage surrounding areas of the spacecraft. Eventually, based on the results of the atomic oxygen test, the project decided to replace the beta cloth on the satellite with a beta cloth without the carbon fibre weave. We are very happy to have contributed to this mission by eliminating a potential risk, and now we are looking forward to the launch of Aeolus when our work will be put to the real test.